Hello everybody, welcome back to our channel kaviwebdesigns, and today I'm going to tell you all about a new chapter called chapter number 5, routing and switching. Previously we have done chapter number 4, which is network devices. Today we're starting with a new chapter, chapter number 5, routing and switching. Now what is routing? Routing directs data between different networks, determining the best path using routing tables. Now, what is switching? Switching manages data within a local area network or a LAN, ensuring it reaches the correct device via MAC addresses. So, as you can see here is routing and switching, a diagram of routing and switching. So, as you can see here in this R1, the router 1, here it's giving the network to this router, which is wirelessly connecting to all of these hosts. And the router number 1 is also having Ethernet cables and giving a network to 3 different hosts using Ethernet cable. And as you can see here, the internet from these 3 hosts will go to router number 2, which connects 2 different networks together. So as you can see here in the router number 3, this is the network number 4, and router number 3 is getting internet from router number 2, and the router number 3 is giving internet to these 2 hosts, which is host 8 and host 9. Now let's move on to our next slide. So our next slide is static versus dynamic routing. So what is static routing? Static routing is manually configured best, and it is best for small stable networks. Now what is dynamic routing? Dynamic routing automatically adjusts based on the network conditions, ideal for larger dynamic networks. So as you can see here is static routing here, and here is dynamic routing. So as you can see here in static routing, here it's only going in a fixed position. So we have manually configured that it must go all the way from here to here to here. So to here, all the way to here. But static routing can't automatically make the easiest path, unlike dynamic routing. So static routing can't just change your manually configured, and what it will do is it will only go in a fixed position. So it will only go up and then down and then up and then next to the dynamic routing. Now let's see dynamic routing. So as you can see here in dynamic routing here suppose this network wants to send a message to this network. So what it will do is it will find the best path for sending the message. So as you can see here it will send it from here to here. You can send it, the easiest path can be like from here to here and then all the way to here. But what if there's a cut from these 2 networks? If there's a cut from these 2 networks, or there's a condition that they can't send any message to this network, to that network, it will send the message to this network, and this network will send the message to this all the way to here. Now let's move on to our third slide. Now we have the routing protocols. The routing protocols can contain RIP, OSPF, and BGP. Now let's see what is RIP. RIP, or Routing Information Protocol, is a simple protocol that uses hop count to determine the best path, and it is suitable for small networks but insufficient for larger ones due to its limit of 15 hops. Now let's move on to OSPF. OSPF, or Open Short Path First, is a more advanced protocol that uses link state information to find the shortest path. So it is a dynamic routing, and it is scalable and ideal for larger complex networks. Now let's see what is BGP. BGP, or Border Gateway Protocol, is primarily used for routing between different organizations on the internet. It focuses on the best path based on politics and rules rather than just shortest route. So as you can see here in this picture here as you can see here, we have the routing protocol called RIP, and this routing protocol uses a static route or a default static route to go to other networks. And as you can see here OSPF is using the BGP routing protocol, which is board gateway protocol, which is secure and more stable. And as you can see here is the OSPF company here. As you can see here they are all using the BGP or the border gate protocol to go to other networks. Now let's move on to the next slide to learn about more. Now the switching components, which are VLAN, STP and port mirroring. Now as you can see here, VLAN or virtual local area network. VLANs allow you to segment a network into smaller isolated groups, improving security and performance. Devices in the same VLAN can communicate as if they're on the same physical network, even if they're in different locations. Now let's move on to STP switching component. STP or snapping tree protocol is used to prevent network loops in a switched network by detecting and blocking redundant paths. This helps maintain a stable and loop-free network topology. Now let's move on to port mirroring. Port mirroring allows network traffic from one port to be copied and sent to another port for mirroring or analysis, often used for network troubleshooting and performance monitoring. Now as you can see here in this diagram here this host is trying to send some data to this data monitoring device. So as you can see here what will happen is this host has the original packets and will send it to the source device. The source device has a source port which will be sent the data to this intermediate device through VLAN, and it will send it to this common port of the intermediate device. And the common port of the intermediate device will send it through another VLAN to the destination device, which has another common port. And here the destination device will use its monitor port to give the same original packets, but copy it and give it to the data monitoring device. So folks, that's it for today. And if you like this video and you want to support us, please like, share, subscribe to our channel Kavi Web Designs. And this is Bhavik signing off.